Hi everyone. In this video we're going to cover topic 1 for chemistry. So let me share my PowerPoint screen with you. Okay, so this is topic 1. We're going to be covering a couple of things in the following video. We're going to be covering states of matter, classes of matter, properties of matter, and the scientific method in topic 1. So what this means is that in order to master topic 1, you need to answer a question that's going to relate to all of these concepts. And if you pass that question, you complete it with, you complete everything, you don't miss anything, then you have effectively mastered topic 1. So we're going to talk about what this topic is and what it entails. So the learning objectives for topic 1 are one that you're going to be able to describe physical states of matter, so things like solids, liquids, and gases. You're going to be able to recognize and differentiate physical versus chemical properties. Also, being able to distinguish mixtures versus pure substances. And then lastly, we're going to talk about the scientific method. So hopefully you'll go from crazy scientists to methodical scientists, where you understand and appreciate a little bit more what you're doing in chemistry. Okay, so this topic involves a lot of definitions, so do hang in there with me. That is a lot of what we're going to be covering in this introduction topic. So first of all, I wanted to define what chemistry is. That's what we're studying. This is a study of composition, structures, and properties of matter. This is a really broad category. Then we're going to talk about matter. So matter is a thing, and it is anything that occupies space and has mass. So that is a lot of things. That's pretty much everything. So everything, like almost all things, fall under matter. Very, very broad definition. And we're going to break this down into smaller subcategories so that we can understand the terms that we're using in this class. So what is mass? If matter has mass, what is that? It defines a quantity, an amount of matter. So let's talk about the different states of matter. So we've got 3 that we're going to discuss in this class. There's another one called plasma, which we are not going to talk about. We're just going to talk about these 3. The first one is a solid, which is something that has a definite shape and volume. So something like this pen here, this is solid. It has a definite shape and volume. Then we have liquids. Liquids are things that occupy a specific volume, but they flow to assume the shape of its container. So like if I put water in this cup, right, the water is going to assume the shape of the cup. But if I put this pen in this cup, the pen is not going to assume the shape of the cup. So that's the difference between our liquids and solids. The next one is gases. So gases are vapors, and these are types of matter that neither have definite shape nor volume. So they aren't easy to see in that sense. And they expand to fill their container. So assume that this cup had a lid on it, right? And you put a gas in here. Unlike the liquid, which is going to sit at the bottom of the cup, the gas is going to expand to fill the entire container. So if I put anything in here, it's going to fill the whole thing. So those are our main differences between solids, liquids, and gases. Now, oftentimes we see matter transition in between these states. So it'll go from solid to a liquid, liquid to a gas, or vice versa. And this is what we call a state change or a phase change. And this often occurs due to an addition or removal of energy, usually in the form of heat. So here is an example on the side over here of what our different states of matter look like in a container. So we've got a solid here on the bottom where our molecules are very close together, tightly packed. And then the molecules move further apart and they fill the container volume, the shape of the container. They assume the shape of the container. And then they get even further apart as a gas and they fill the entire container. So we have these different terms that we use to discuss changing states of matter or phase changes. So the first one of these is freezing. Freezing is when you go from a liquid to a solid. So like when you freeze water, right, and you turn it into ice. We have melting, which is the opposite. So when you're melting ice cubes, it goes from a solid to a liquid. Condensation. Condensation is the effect that happens when you have like a cold glass of liquid, usually water or something, outside on a hot day, and you see that water starts to bead on the outside of the cup. What's happening there is that the water vapor in the hot air outside is coming into contact with the cold cup, and it's cooling down the water vapor so that it goes through a phase change. It goes from a gas to a liquid, and it beads on the outside of the cup. So that water you see on the outside of the cup is actually coming from the air around you. Then we have vaporization, which is the opposite effect, where we're going from a liquid to a gas. You often see this whenever you're drinking hot liquids, beverages, so things like tea or coffee or hot chocolate. You'll see the steam coming off of your hot cup, and that is a vapor. That's water vapor. Then another process that you might see, or actually you won't see this, another process, another phase change that I want to talk about is sublimation. This is not a common phase change, but it's really cool and it does happen, so I'm going to show you this one. That's when we go from a solid straight to a gas. Deposition is the opposite, when we go from a gas straight to a solid, so we skip the liquid phase entirely, which is an unusual phenomenon that only happens for certain types of matter. Another thing that I want you to really understand here is that energy is required to pull these molecules apart and to move them apart, which is why we often have to heat things or cool things down, all right? So when we're heating things, that means energy is going into the system. We're putting energy in, and what that's doing is it's helping these molecules move apart. So when we give them more energy, they can move around a lot more, right? When we cool them down, they move around a lot less. And so we're seeing our molecules either pull apart or come together based on the energy in the system. This is a concept we're going to cover in later chapters and more in depth, but I do want you to understand this and get a grasp on why these molecules are coming apart in the first place. Okay, so I want to take a brief minute to show you the sublimation and deposition of iodine because it's really cool. So I wanted to YouTube, I think I've got the sublimation iodine. Cool, this is exactly what I wanted. So I'm going to turn off the volume here and I'm just going to talk over it. So these are iodine crystals that you're seeing here. So they're going to show us what happens when you take solid iodine, which is this blue-black stuff, and you heat it up. And so what's going to happen is sublimation. So you apply heat to the granules, and they turn into this vapor, this beautiful purple vapor, which is where iodine's name actually comes from. It comes from Greek. All right, and so now what they're going to do is they're going to do the opposite process of sublimation, which is deposition. So they're taking a flask with ice on it. So they're going to cool down this vapor, take the energy out of it, and what happens is it reverses phase again. So it goes from this gas straight back to a solid, which is a very cool process. So it'll just take just a minute. All right, so there is the iodine crystals reformed on the outside of the cold glass. So that is the process of sublimation and deposition, and only a few substances do this. Iodine is one of those, so I wanted to show it. It's also just really, really pretty. Okay, so let's go back to PowerPoint. If it will let me. Here we go. Okay. Again, going back to that concept of molecules and atoms and matter moving around, this is something I really wanted to stress. Because as students, when you're learning about chemistry, we tend to get kind of stuck in our head that like atoms and molecules always look one way. They're always in this state, which is just not true. In reality, matter is always moving. So even things that are solid, all the molecules and atoms inside this pen are in motion, even though we can't see it. Molecules are always rotating, vibrating, colliding with each other. They're interacting with each other, pushing, pulling. There's all kinds of forces that we just can't see. And these forces change when your substances go through different phase changes. And that's really evident in this graphic here. You can see the solid is kind of vibrating, very small motions. As we put energy into the system and we heat it up, there's more movement happening. And then when we heat it even more, gases expand and the molecules just explode apart and they're ricocheting off everything because they have so much energy, which is one of the reasons why they expand to fill a container like this. Okay, so let's get into some more definitions. Yay! So let's talk about classes of matter now that we understand a little bit the different phases of matter. So pure substances, we can split different types of matter into two things, a pure substance or a mixture. So a pure substance is one that has the same chemical and physical properties throughout the substance. And it cannot be separated into simpler substances by a physical process. So physical means is like, pulling something apart or filtering it, something that is not a chemical reaction. That's what a physical process is defined as. So like melting or freezing, those are physical processes. So a physical process, again, is a transformation of a sample of matter that does not alter the chemical identity. And those phase changes are an example of a physical process. Now let's talk about mixtures, since we've talked about substances. Mixtures are things that have different types of substances in them. So an example of this is gasoline. If we look at gasoline, it has an octane rating on it. Now octane is a molecule. It's got 8 carbons in it, which is why we call it octane, octa for 8, right? Just like an octopus. So over here we have these octane ratings. So an 87 octane rating means that the gasoline has 87% octane in it. So the rest of the gasoline is not octane, meaning that there are other types of molecules in here. There's other types of things inside of that mixture. We can also see that in this graphic here. You can see that there are different types of molecules. So the number of carbons means it's a different molecule. If it's got 2 carbons, that's one substance. If it's got 3 carbons, that's an entirely different substance, right? And so we're seeing here things like our natural gas have smaller amounts of carbons in them. And you can see here that it's a mixture because if it was not, it would only have one of these substances in it. So it would say it has 1 carbon in this specific type of gas. However, it's got a range 1 to 4, which means it can have all of those in there. Gasoline, so again, we want to optimize octane in our gasoline. So 8, it's in the range right around 8, but it can be anywhere from molecules with 5 carbons to 10 carbons in it for gasoline. And we're seeing here that these different types of fuel sources are separated out by heating. So you can see here, we've got some heat, and we're seeing the liquids separate from the vapors, and that's how they are separating out these different molecules here and these different fuel sources, which are used for different purposes. Okay, so we split matter into substances and mixtures, and we talked about how you can physically separate mixtures using things like heating. We saw that with the gasoline process. We can heat it in order to separate out the different types of molecules. And if we refine that further enough, we can split those mixtures into individual substances. Like if we kept working on that boiling process, we could split it into just one molecule with, say, like 1 carbon in it. So the liquid would only have 1 carbon in it. So you could continue to refine things to do that. So you could separate mixtures into substances using physical means. But let's talk about these substances here, these different types of substances, because we have several. And these are important to understand for chemistry because we're going to be using these terms a lot. One of those is an element versus a compound. So an element is a pure substance that cannot be separated into simpler substances by chemical processes. So a chemical reaction. This is not a physical, the physical separation. We're talking a chemical reaction. So an example of that is like this gold up here. I've stuck with the gold example. You'll see that a lot when I'm talking about it. And you can see that there's gold atoms. So there's a bunch of gold atoms stuck together. There's no other types of atoms in there. That's it. However, a compound is a substance that's composed of 2 or more elements. that are bonded together, chemically bonded together. So an example of that is water that's shown down below. We've got an oxygen atom connected to 2 hydrogen atoms. These are different elements. All right, and these elements can be broken down, or these compounds can be broken down into individual elements by chemical reactions, not physical processes. We're talking chemical changes. Another way to remember what's an element versus a compound is looking at the periodic table of elements. This is a nice shortcut that I like to take. If it's on the periodic table of elements, and that is the only thing in the substance, it's an element. So if you've just got helium in your sample and that's it, then it's an element. Or just gold, gold's here, Au, it's an element, all right? That might help you remember that definition. Now our compounds, like I said, can be broken down by chemical means into elements. And we can see that here when we run a current through water. So this is a chemical reaction that we're seeing going on here. We're actually causing electrons to move around in the atoms by running a current through the water. And what happens is this energy, this is a type of energy, it's not heat energy, but it is energy. It takes those chemical bonds and breaks them apart. And so we see oxygen and hydrogen gas being formed by this chemical change. And so that's breaking our water down into its separate elements. Okay, so in the next video, we will talk more about mixtures.